Today, we are continuing understanding how to calculate compound interest. In our previous lesson, we calculated compound interest using the simple interest formula and then calculating it every time we compounded the interest. In today's lesson, we're going to find the compound interest using the compound interest formula. So that compound interest formula looks like this. A equals P times the quantity of 1 plus R to the nth power. So let's look at what each one of these variables mean. A is going to represent what our future amount is. P is representing, just like it did before, our principal, which is your initial investment. How much money are you putting into your account? R is a little different today from simple interest. In simple interest, we just put our annual interest rate. For R in our compound interest formula, we have to take our annual interest rate and divide it by the number of periods that we have. And then N is going to be calculated by finding how many times we're going to compound that in the amount of time we keep that money sitting in that account. So let's look at how to use these variables and calculate an amount. So PNC Bank pays 5% interest compounded quarterly on regular savings. Sarah deposited $2,000 and she just let that money sit in her account. She didn't make any withdrawals. She didn't make any other deposits. How much interest did Sarah earn during the 2 years? So we are looking for the amount. So I'm going to break down what all of our variables are. So our principal is her initial investment, which is the $2,000. Our rate is, so PNC has a rate of 5% annually. So we're going to take that and turn that into a decimal, moving that decimal 2 places to the left or dividing by 100 and dividing it by quarterly, because we are going to compound that 4 times in that year. Then N, how many times is it going to be compounded? So in 2 years, if we compound it 4 times, we're going to have 8 periods that we are going to compound that interest. So now let's throw this all into our formula. Our amount is going to be 2,000 times the quantity of 1 plus, and I put this right into my calculator just like this, all raised to the 8th power. Now if you need to put that into your calculator, you should be looking for the caret button. That's your power button that's going to raise that to the 8th power. So when I put this in the calculator, I put it in just like this using the parentheses. I even put the 0.05 divided by 4, and then I'll use that caret button and I'll put the 8, and it should place that 8 exactly where you need it to go in a scientific calculator. So after doing this calculation, I found that Sarah, after 2 years, has $2,208.97 in her account. So now if I need to calculate interest, that's a quick formula. We're going to start with her new amount, and we're going to subtract out her original principal. So her interest that she earned in 2 years was $208.97. So this is her final amount in her account, and that is the amount of interest that she earned. Let's try one more of these together to make sure that you understand. So Community Bank pays 3.5% interest compounded monthly on regular savings accounts. Will deposited $5,200, so that is his principal. His rate is going to be 0.035 divided by, since we're compounding it monthly, we're going to divide that by 12. In 3 years, he made no other deposit. So our period is going to be, so he's keeping that money in for 3 years and he's compounding it monthly. So he's going to have 36 compounds or 36 periods within that time frame. How much interest will Will earn during the 3 years? So let's first calculate the amount. So we'll start with the principal of $5,200 times the quantity of 1 plus our interest rate divided by the number of periods per year. And that's going to be raised to the 36th power because we're keeping that money in there for 3 years. So after I put that into my calculator and calculate, I find that Will has, at the end of 3 years, $5,774.81 in his account. And to calculate his interest, we're going to subtract from that amount, that initial $5,200. So his amount at the end will be $5,504.81. Let me try that again. So we're going to take $5,774.81 and subtract $5,200 from that. And his interest is going to be $574.81. Okay? So now you try. Go ahead and pause the video, look to page 229 in your textbook, and look for questions 3 and 4. When you return, you can find the solutions on the next slide. All right, so for number 3, after calculating 4 quarters for 40 periods, our amount at the end is $94,344.88, and the amount of interest we learned in those 40 periods were $44,344.88. In the 4th problem, we had to set up a little bit of an algebra problem because this time we knew the amount, but we were missing the principal. So we had to reverse everything a little bit. So we put 100,000 for the A. We were looking for P, so that we kept P in there, and then ran this 1 plus 0.066 divided by 2 for semi-annually to the 40th power. So what I did first was I multiplied this all out and raised that to the 40th power. That gave me about 3.6645. I had to round that a little bit. Then I divided both sides by 3.6645, and I found that the initial principal was $27,288.97 in order to end up with $100,000 in the end. All right, I hope this explains how to find the compound interest a little bit easier today.